Gentlemen, today we're going to be reviewing some of the key concepts to see what you can put into your project, your creative project about how to present this first half of the unit. So specifically today we're going to focus on the irrational and rational numbers part. Can you classify rational and irrational numbers? And can you place them on the number line? So some key concepts about that is that numbers are broken into categories. The two main categories are rational and irrational. For rational numbers, it's basically most of the numbers you know, numbers that can be written as fractions of integers over integers, which is pretty much every number we work with. It even includes some square roots, specifically square roots of perfect squares, like the square root of 4, which is just 2, the square root of 9, which is just 3, the square root of 16, which is 4, the square root of 25, which is 5, and so on. Irrational numbers have decimals that never end and never repeat, and they are essentially limited to, at least for our purposes, pi, 3.14159, dot, 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 and square roots of non-perfect squares, like the square roots of every number in between, like the square root of 3, the square root of 5, 6, 7, and 8, the square root of 10, 11, 12, 13, 14, 15. Those square roots are irrational. There's no number you can multiply by itself and get 5 or 6 or 7 or 8. So they're irrational. So by the end of today, hopefully you have three major things that you can put into your project, three major key ideas that you can creatively put into your poem or song or art project that shows you have learned it and understood it. So let's look at this first problem. If a number is rounded to the hundredths place, so if I'm telling you that this number is rounded, can you tell if it is rational or irrational? For this, no, you cannot tell if a rounded number is rational or irrational because it is rounded. We do not know what comes after the hundredths place at this point. It could have been a never ending, never repeating decimal, or it could have just been a 9 in the thousandths place. So for this, that kind of gets to one of the key ideas of rational and irrational. A rational number would, like 12.32 is a rational number. But since it was rounded, we don't know what the original number that started this was. Was it 12.3197632 that went on forever? Or was it 12.3198 that just ended? We don't know. Was it 12.31999999, which would have also been a rational number since it repeated? But since it was rounded, we couldn't tell. So with that, see if you can try this one. If a number is rounded to the thousandths place, like 0.125, can you tell if it is rational, irrational? And answer that question now. About this, of the following numbers, which ones are rational? Well, A, the square root of 49 is a square root, which originally makes me think it's irrational because most square roots are irrational. But then I say, wait a minute, square root of 49 is 7. That's a perfect square. And 7 is a rational number. And since the square root of 49 is equal to 7, and I know 7 is a rational number because I could write it as a fraction of 7 over 1, then I know the square root of 49 must also be rational. B, since this decimal never ends and never repeats, it says 508, 508, 507, and then dot, dot, dot. That dot, dot, dot is a key indicator that we're talking about an irrational number, because if it repeated, we would have that line over a number. But since it's got the dot, 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 that's an indicator that this decimal goes on forever and it doesn't repeat. Therefore, B would be irrational. So far, the only choice we have is A. C, well, 8 over 9 is a fraction, which is the definition of a rational number. It's two integers written over the top of each other. Therefore, it has to be a rational number. We also know that it's 0.8 repeating, and we know repeating decimals are rational. So far, A and C are rational numbers. D, square root of 10. Well, most square roots are irrational unless they're perfect squares. Uh, we don't know the square root of 10. We know the square root of 9 is 3. We know the square root of 16 is 4. But the square root of 10 is in between those. There's no number that we can multiply by itself and get exactly 10. Therefore, the square root of 10 is a non-perfect square, which makes it irrational. So far, our choices are A and C. For E, I have this repeating line, which means that this is 6.2525252525, and we know repeating decimals can be written as fractions and are rational. Therefore, A, C, and E are rational. Now you try this one. All right, number 3. Um, let's see if we can start placing these numbers on the number line. Square root of 74, is that between 7 and 8? Well, I know the square root of 49 is 7, and the square root of 64 is 8. So any square roots between 49 and 64 must be between 7 and 8. Since the square root of 74 is bigger than that, it must be larger than 8 and not between 7 and 8. Therefore, A is false. For B, 3 times the square root of 10, is that between 9 and 10? Well, the square root of 10 is a little bit bigger than 3. Let's call it 3.1, because we know the square root of 9 is 3. So if square root of 10 is about 3.1, it's an irrational number. We can estimate it though. And 3.1 times 3 would be 9.3. That is between 9 and 10. So B is true. The square root of 10 is between 3 and 4. But if you multiply it by 3, you'll get between 9 and 10. So B is true. So far, the only one that's true is B. C, the square root of 2. We know the square root of 2 is about 1.4, if you remember from your chart. It's an irrational number because there's no number you can multiply by itself to get 2. But we can estimate it to about 1.4. And 1.4 times 4 would be about 5.6, which is a little bit bigger than 5. Therefore, it is false. So 4 times the square root of 2 is not between 4 and 5. The square root of 29. Well, we know the square root of 25 is 5. We know the square root of 36 is 6. And the square root of 29 is between the square root of 25 and the square root of 36. Therefore, the square root of 29 is between 5 and 6. So D is true. So far, the only ones that we have are true are B and D. Is 2 times the square root of 50 between 15 and 16? Well, the square root of 50 is a little bit bigger than the square root of 49. We know the square root of 49 is 7. So since we'll call it 7.1. So 2 times 7.1 would be about 14.2, which is not between 15 and 16. Therefore, E is false. So the only ones that are true are B and D, and the ones that are false are A, C, and E. You try this one. For our fourth problem, see if we can figure out where each of these numbers go on the number line. Well, it looks like B is between 6 and 7. Well, the square root of 85, we know that's a little bit bigger than 9 because the square root of 81 is 9 and the square root of 100 is 10. So the square root of 85 actually must be point C. So point C has to be the square root of 85 because it's a little bit bigger than 9. Let's jump down to C because that's a little easier. Square root of 56. I know square root of 56 is a little bit bigger than the square root of 49, and the square root of 49 is 7, and the square root of 64 is 8. So point C, or square root of 56, has to be between 7 and 8, and that must be point D. So square root of 56 is here. Square root of 85 is here. That leaves me with these two. Well, here there's no square root. It's just pi. I know pi is about 3.14. It's irrational, as all these numbers are. Uh, but I know it's about 3.1. And if you multiply by 2, you get about 6.2. And that would be this. So far we know A must be, square root of 85 must be point C. 2 pi must be point B. Square root of 56 must be point D. And that leaves 3 times the square root of 15 must be this over here. And let's double check it. Square root of 15 is a little less than the square root of 16. Square root of 16 is 4. 4 times 3 is 12, so it must be a little less than 12, and there you go. That's where that is. See if you can do this one. And for our last problem today, which expressions must be bigger than 12 and a half? Well, let's see, the square root of 130. I know the square root of 144 is 12, and this is less than the square root of 144, so A cannot be bigger than 12 and a half, because it's certainly not bigger than 12. It's less than 12. 4 times pi. Well, pi is about 3.1, 3.14. 4 times 3.14, 4 times 3.1 is 12.4. So it's a little bit less than 12.5. I wonder if I take it out, though, if I say 4 times 3.1, I know is 12.4, which is not 12.5. But if I do 3.14159, does that move it up enough to get it bigger than 12.5? It does. So if I take that out, it's really, really close. But actually, 4 times pi is bigger than 12.5. So A is not a choice, but B is bigger than 12.5. 2 times the square root of 95. Well, the square root of 95 is a little bit bigger than the square root of 81, which is 9, a little bit bigger than the square root of 10. Well, I'm sorry, square root of 100, which is 10. And if I took the lower end of that, square root of 81 is 9, and 9 times 2 is 18. So it's definitely bigger than 12.5. So 2 times square root of 95 is definitely bigger than 12.5, because even if this was just the square root of 81, 2 times the square root of 81 is bigger than 12.5. Now here, I don't have 8 times the pi, I have 8 times the square root of pi, which if you remember we did last week. Square root of pi is a little bit bigger than the square root of 3. I know the square root of 4 is 2, so we know the square root of pi is like 1.7. And 1.7 times 8 is going to be pretty close. So let's check that. Uh, 8 times 1.7, 13.6. And so therefore, this is bigger. It's pretty close. And the square root of 142. We know the square root of 144 is 12. And this is less than that, so it has to be less than 12.5. So A and E, we know right away are not true. B was very close, but is bigger than 12.5. C is definitely bigger than 12.5. And then D we also found is bigger than 12.5. So B, C, and D are right for this one. And for your last problem, see if you can try this one. And as we end today, what are 3 major things that you can take from these problems? 3 major ideas or skills that you can somehow put into your song or your poem or your art project to show me you really understand rational, irrational numbers, both where they go on the number line and how to classify them.